Hi friends, welcome to somethingcalledscience.com. Today we'll talk about the naming rules for monoatomic ions. So, as you likely know, there are different types of ions. In this video, we'll discuss one particular type of ion, namely monoatomic ions, and specifically what the naming rules for this type of ion are. Monoatomic ions are ions that consist of one atom. This is different from another type of ion called polyatomic ions, which are made up of two or more atoms. If you would like to know more about the difference between monoatomic and polyatomic ions, or about the naming rules for polyatomic ions, we have separate videos about these topics. Now, for this video, we will focus specifically on the question of how monoatomic ions are named, because there are specific rules for how this naming is done. So the specific rules for how monoatomic ions are named depend on whether the ion is a cation, so a positively charged ion, or an anion, so a negatively charged ion. For monoatomic cations, the name of the ion is the same as the name of the element, so there is no difference between the name of monoatomic cations and the name of the element. For example, a sodium ion is a monoatomic cation and it is named sodium, just like the element sodium. As another example, a calcium ion is also a monoatomic cation and it is named calcium, just like the element calcium. So the naming rules for monoatomic cations are pretty straightforward, because the name of the monoatomic cation is identical to the name of the element. This is true across the board, but there is one important exception to this rule. This exception applies to one particular group of elements where the naming rules are a bit different, and this is the group of elements called transition metals. As you might recall, there is a group of elements in the central block of the periodic table of elements that is called transition metals, and they include, for example, iron, copper, and gold. What is important to understand is that transition metals differ from other elements in a way that's important for our purpose, namely, they have the ability to exhibit multiple oxidation states. What that means in simple terms is that they can lose different numbers of electrons. For other elements that are not transition metals, this is not the case. These elements can only lose one specific number of electrons. For example, sodium can only lose one electron, resulting in a sodium ion, and calcium can only lose two electrons, resulting in a calcium ion. However, when we take a transition metal such as iron, we see that it can lose different numbers of electrons. For iron, the most common oxidation states result when it loses 2 or 3 electrons. So Fe2+ and Fe3+ are the two primary oxidation states of iron. So what does this mean for the answer to our original question, namely, what are the naming rules in this case? If we have two oxidation states of iron, Fe2+ and Fe3+, we can't really name both simply an iron ion, like we would with other monoatomic ions, because then we don't know which of the two oxidation states we are referring to, Fe2+ or Fe3+. So how have chemists solved this issue? Well, they've come up with a rule for this, which is to include Roman numerals in parentheses to the name of the element. In the case of iron, Fe2+ is named iron with in parentheses the Roman numeral 2, and Fe3+ is named iron with in parentheses the Roman numerals for 3. And this solves our issue because the Roman numerals in parentheses make it possible for us to differentiate between the different oxidation states of transition metals. So this is how we name monoatomic ions from the group of transition metals. So to quickly recap what we've talked about up until this point, we've looked into the naming rules for monoatomic ions and specifically for monoatomic cations, which are positively charged ions. Now let's look at the naming rules for monoatomic anions, so negatively charged ions. For monoatomic anions, the name of the ion is derived from the name of the element, but the ending of the name is changed to IDE. For example, chlorine becomes chloride, oxygen becomes oxide, and nitrogen becomes nitride. Note that we don't just add IDE to the element's name, because then chlorine, for example, would become chloranide, and that is not the case. So instead we take the root of the element's name, which in the case of chlorine is chlor, and we add IDE, and this leads us to the name of the monoatomic anion, which in this case is chloride. Although this naming rule is fairly straightforward, for some elements things are a little bit less straightforward than for others. For example, the monoatomic anion of iron is not called ironide or iride, but instead it is called ferride. This is because the Latin word for iron is ferrum. It is common in chemistry that the names of elements are based on Latin or Greek. You can see this also in other examples. For example, copper comes from the Latin word cuprum, so the monoatomic anion is called cupride, and lead comes from the Latin word plumbum, so the monoatomic anion is called plumbide. So you have to go back to the original names of the elements to be able to derive the name of the anion. Now, different than for monoatomic cations, where we have an exception to the general naming rule, namely for transition metals, the naming rule for monoatomic anions applies across the board. In other words, the rule that monoatomic anions are named by changing the ending of the element's name to IDE applies universally to all monoatomic anions with no exceptions, not even for monoatomic anions from the transition metals group. So, to recap the naming rules for monoatomic ions, let's look at a brief summary of what we've learned so far. Monoatomic cations are named after the element, for example sodium or calcium, or with a Roman numeral for transition metals, for example iron, within parentheses the Roman numeral for 2, or copper, also within parentheses the Roman numeral for 2. Monoatomic anions, on the other hand, are named by taking the root of the element's name and adding the suffix IDE, for example chloride, oxide, or nitride. If you found this video helpful, don't forget to like, subscribe, and hit the notification bell for more science content. It really helps the channel. Let us know in the comments if you have any questions or topics you'd like us to cover next. Thanks for watching and see you in the next video.